Hi guys, assalamualaikum and good day. Alright, in this video we are going to start talking about the last chapter for your syllabus, which is partial derivatives, right, in chapter 5. Alright, so what is a partial derivative? Okay, we already know what is derivative. Okay, we can assume that the one that we have learned before in the previous chapters, right, we fully differentiate all of the functions. Okay, however, there's a situation where we can't really find derivative as we commonly did in the previous chapter, because there will be this kind of function. Okay, consider this following function. We have previously we only have f in the bracket x, or we can have x in the bracket y. In other words, we only have a single variable in the bracket. So all of our function will be described with respect to that variable. So all of the variable in that function later will be just one variable. So we have x squared plus x and so on. However, for this case, we have not just one variable, we have more than one variable. So you can have x1, x2 till xn. In other words, in your functions later, you will have a mix up of several variables. Okay, so in our previous chapter, we have this x as a single variable. So when your x is a single variable, we only have one variable in a function, and you can just use a derivative method, right, that we have learned in our previous chapters. But however, if you have more than one, okay, this is what we are going to do. Right, the variable that we are going to differentiate, right, we are going to conduct a derivative just like we did in the previous chapter. As for other variable, let's say you have x, y, and z. Y and z will be will act as constant. So we are not going to conduct derivative for the variable that we are not interested in at that moment. Okay, so this is how you denote partial derivative. We have partial f over partial x. This is if you want to differentiate the function with respect to x, and this is if you want to differentiate the function with respect to y. The notation is somehow similar, but it is different a bit from our dy dx, because this is to differentiate it from a normal derivative that we did in our previous chapter. So this indicate partial derivative. Now, that is not really an issue when you conduct the first order partial derivative. Now, when it comes to the second order partial derivative, it can comes in several ways. First, you might want to, so let's say you conduct a derivative with respect to x. Secondly, you also want to conduct it with respect to x. So you are going to have this. This is the second derivative with respect to x. So this is quite common. We have already did this in our previous chapter, and this is also the notation when you want to differentiate y two times, right? The first time and the second times. And we have one more situation in partial derivative where you have mixed derivative. We call it mixed partial derivative, where at first you might want to differentiate y, then you'll go the second derivative will be on x. So you have this notation. Right, the same goes for this one. If you want to differentiate for x and then y, you'll have this notation. The arrangement is a little bit different. However, they are actually the same. So if you conduct this one, if you differentiate the second order for this one or this one, it means that if you start with y or if you or x and then you finish with x or y, you should get the same function, right? For these last two mixed partial derivatives. So there is not really an issue there whether you want to differentiate which one first. Okay. So that is the additional thing that we have in partial derivative. Now, let's see on how do we conduct partial derivative. Just by using this idea. So if you want to differentiate it with respect to x, let's say x here, if you have other functions such as y, you are going to treat y as constant, meaning that we are just going to look at y and think of it as a number, not y. Alright, so let's try to do that. Let's look at example 5.1 first. Okay, let's look at the simple one first, which is we have two functions of x and y in our function here. Alright, so let's try to differentiate it, right, with respect to x and later to y, and let's also look at the mixed partial derivative. Okay, so let's start with that. Alright, because of we want to focus on x only, so other than x will be assume a constant. So 3 is a constant, of course. Y will also be considered a constant. The same goes for this one. 2 is a constant. The same goes to y squared. And the same goes to y to the power of 3. All of them will be considered a constant. So what happens when we want to differentiate a constant? We will split them, right? So this is how we split constant from our function, right? You don't need to really do this all the time. This is just for the first time only, right? Just to make sure that you understand what does it mean by make it as a constant. So I pull 3 and y out. I just differentiate x squared. I pull 2 at y squared out. I just differentiate x. The same goes for this one. I pull y to the power of 3 out. So basically, those outside behind the derivative don't need to be differentiated. So we'll just differentiate x, right, as usual. And lastly, this is what you should get. Okay, this is the answer for the partial derivative of x. Okay, let's do for the rest, for y and for the partial derivative. Alright. So let's try to do the second derivative of x. So basically we will still want to focus on x, and 6y will become a constant. So we get 6y plus, as for this one, we don't have x here. So basically, we just consider this as not exist actually for us to conduct a derivative. So we just look at those that have x, right? So the answer here will be 6y only. Alright, let's look at the second one. We want to differentiate it based on y. So look back at our original function. 3x squared constant. So y become 1. So 3x squared plus 4x, right? And then we have here 3xy squared, right? Just in case you feel a bit lost, so let's try to look at it step by step. So 3x squared y, so 3x squared is become a constant, pull it out. 2x constant, same, pull out, and then the same goes for this one, x, pull it out. Only left us with y. So differentiate it, and this is what you get. Okay. Now let's look at the second derivative of y. So we should refer to this one. Alright. So okay, for this one there is no y here, so we consider it non-existent. We only look at those with y. So you will get 4x plus 6x y, right? Okay, that is for the first and second derivative of x and y. Now let's try to look at the mixed derivative. For this one, we'll start with the differentiation of x, and the second derivative will be on y. So because of the first derivative is on x, we'll need to refer to this. Alright. However, to find the second derivative, we will use this. However, we will be looking at y. So for this one, if you differentiate in terms of y, you will get 6x plus 4y plus 3y squared. Right? If you conduct a mixed derivative the other way around, you look for y first. Look for the second derivative by looking at the derivative of y as the first derivative. You will get the same answer, right? When you look at x later. For this one, right? You're looking at y first, and then you want to look at x later. So you are going to refer to the derivative of y first. And secondly, when you're looking for x, you're going to look at this function. So we have 6x, and this one will become 4y, and this one will become 6y. Sorry, this one will become because of y squared is a constant, right? So 3y squared, right? So you should get the same answer for this two mixed partial derivative even though they start at a different function. Okay, so that is for an introduction for partial derivative. Thank you.